Hey there, science fans! Welcome back to another exciting episode where we dive into the fascinating world of technology and the internet. Today we're going to unravel one of the most fundamental aspects of the internet that makes all our online activities possible. It's how we connect with friends, watch funny cat videos, and learn about amazing things. From streaming your favorite shows to video chatting with loved ones across the globe, the internet is an integral part of our daily lives. But have you ever wondered how your computer finds its way around the internet? How does it know where to send your messages or fetch the information you need? That's where IPv4 comes in. IPv4 is a crucial component of the internet's infrastructure, acting as a guide to ensure data packets reach their intended destinations. IPv4 stands for Internet Protocol Version 4. It's a set of rules that governs how data is sent and received over the internet. Think of it as a universal language that all internet-connected devices use to communicate with each other. Without IPv4, the seamless exchange of information we enjoy today wouldn't be possible. Imagine the internet as a vast postal system. Just like every house has a unique address for mail delivery, every device on the internet needs a unique address to send and receive data. This is where IP addresses come into play. Every computer, smartphone, and even smart appliances like your fridge or thermostat needs a unique address to communicate on the internet. This unique address is known as an IP address. An IP address is a series of numbers separated by dots. In the case of IPv4, it consists of 4 sets of numbers, each ranging from 0 to 255. An IPv4 address looks like this: 192.168.1.1. This format helps ensure that each device has a unique identifier. Each number in the address represents a part of the location of your computer on the internet. The structure of these numbers helps route data efficiently, ensuring it reaches the correct destination. When you send an email, stream a video, or browse a website, data packets are sent from your device to the destination device using these IP addresses. The process is similar to how a letter travels through various postal hubs before reaching its final address. Just like a GPS system helps you navigate roads, IPv4 helps data packets navigate the complex pathways of the internet. Routers and switches along the way read the IP addresses and direct the packets accordingly. This ensures that your data reaches the right place, whether it's a website server, an email inbox, or a friend's computer. The efficiency and reliability of this system are what make the internet so powerful and versatile. So next time you send a message or stream a video, remember the incredible system of IPv4 working behind the scenes to make it all possible. It's the unsung hero of our digital age, ensuring smooth and efficient communication across the globe. Thanks for joining us on this journey into the world of IPv4. Stay curious and keep exploring the wonders of technology. Remember how we talked about IP addresses being like addresses for computers? Well, IPv4 addresses are made up of numbers. These numbers are combined in a special way. An IPv4 address has 4 sections. Each section is called an octet. Each octet has 8 bits. A bit is like a light switch. It can be either on, 1, or off, 0. Now, there are different types of IPv4 addresses, each serving a unique purpose in the vast network of the internet. These addresses are essential for routing information to the correct destination, much like how a postal system works. Just like there are different types of mailboxes for different kinds of deliveries, IPv4 addresses are categorized into different classes to handle various scales of network traffic and organizational needs. We call these categories classes. The main classes of IPv4 addresses are A, B, and C. Each class is designed to accommodate different sizes of networks, from the largest corporations to individual households. Class A addresses are like big mailrooms for huge companies. These addresses are allocated to very large organizations with a vast number of devices that need to be connected to the internet. They have a large range of addresses, allowing for extensive internal networks. Class B addresses are like mailboxes for medium-sized businesses. These are assigned to mid-sized organizations that require a moderate number of IP addresses. They strike a balance between the vast range of Class A and the smaller range of Class C. And Class C addresses are like mailboxes for individual homes. These are used by smaller networks such as those in residential areas or small businesses, where fewer devices need to be connected. Each class has a different range of numbers it can use. For example, Class A addresses range from 1.0.0.0 to 126.0.0.0, Class B from 128.0.0.0 to 191.255.0.0, and Class C from 192.0.0.0 to 223.255.255.0. This classification helps organize all the addresses on the internet, ensuring that data packets are efficiently routed to their correct destinations. By understanding these classes, network administrators can better manage and allocate IP addresses within their networks, maintaining order and efficiency in the digital world. Imagine a big office building. It's easier to find someone if you know what floor and department they're on, right? Subnetting is like dividing that building into floors and departments. Subnetting is a way to split a network into smaller networks. It helps manage traffic and makes things more efficient. Section 5. Subnetting in action. A practical example. Let's say you have a network with the address 192.168.1.0. This is a common private IP address used in many home and office networks. It's part of the Class C range, which is typically used for smaller networks. Now imagine you have a large number of devices that need to connect to this network. Without subnetting, all these devices would be part of a single large network, which can become difficult to manage and inefficient. You can use subnetting to divide it into smaller networks like 192.168.1.1 to 64. This means that the first subnet will include all IP addresses from 192.168.1.1 to 192.168.1.64. Each of these smaller networks or subnets can be managed separately, making the overall network more efficient and easier to troubleshoot. Another subnet could be 192.168.1.65 to 128, and so on. By creating these subnets, you can allocate specific ranges of IP addresses to different departments or functions within your organization. For example, one subnet could be used for the marketing department, another for the sales department, and another for the IT department. This way, each department has its own dedicated range of IP addresses, which can help improve network performance and security. This way, you can group computers together based on their function or location. For instance, in an office setting, you might have one subnet for the first floor and another subnet for the second floor. This can help reduce network congestion and make it easier to manage network resources. Additionally, if there's a problem with one subnet, it won't affect the others, which can help improve network reliability. It's like having different rooms in your house for different activities. Just as you might have a kitchen for cooking, a living room for relaxing, and a bedroom for sleeping, subnetting allows you to create different rooms within your network for different purposes. This can help keep your network organized and running smoothly, ensuring that each device has the resources it needs to function properly. Section 6. CIDR. A more flexible approach. CIDR stands for Classless Interdomain Routing. It's a newer way to write and allocate IP addresses. Think of it like using GPS coordinates instead of just a street address. CIDR is more flexible than the old class system. It allows for more efficient use of IP addresses. This is important because we're running out of IPv4 addresses. Section 7. CIDR in practice, real-world examples. With CIDR, you can specify the size of a network using a slash notation. For example, 192.168.1.0/24 represents a network with 256 addresses. This makes it easier to allocate and manage IP addresses for different organizations and networks. It's like having adjustable shelves in your bookcase. Section 8. The future of IP addressing beyond IPv4. IPv4 has served us well, but we're reaching its limits. That's where IPv6 comes in. It's like upgrading from a 4-digit zip code to a 10-digit one. IPv6 uses a much larger address space. This means we won't run out of addresses anytime soon. It's the future of the internet. Section 9. Conclusion. Navigating the digital world with IPv4. IPv4 is the unsung hero of the internet. It allows our devices to connect and communicate. Understanding the basics of IPv4, including classes, subnetting, and CIDR, helps us appreciate the complexity of the online world, and as we move towards IPv6, we can be sure that the internet will continue to evolve and connect us in new and exciting ways.